Welcome. In this video we'll be finding distance, speed, and angular speed. Let's take a look at the example. The minute hand on a watch is 8 centimeters long. Part A, what is the distance the tip of the minute hand travels in 40 minutes? Well, first thing first. Keep in mind that since we're dealing with the watch, we're going to assume that we are going around. So the minute hand will be the radius here. Okay, and that radius has a length of 8 centimeters. As you go around, you're just covering the circumference of the circle. So circumference is 2 pi r, or pi times the diameter. And in this case, we find that circumference to be 2 times pi times 8 centimeters. So this is just 16 pi centimeters. However, that will be the circumference. That includes all 60 minutes. Yet, based on the question, we're interested in the distance that the tip of the minute hand will travel in 40 minutes. Since the whole revolution, or the whole lap, is 60 minutes, we're only taking 40 out of those 60 minutes. So that translates to 4 sixths. And if we were to simplify this after we divide by 2 becomes 2 out of 3, or 2/3. So the actual distance that the tip of the minute hand travels is really 2/3 of the entire circumference, which was 16 pi centimeters. So we multiply those two quantities and we end up with the distance being equal to 32 pi over 3 centimeters. So that's the distance the tip of the minute hand travels in 40 minutes. Now let's take a look at the next part of the question. At what speed is the tip moving in centimeters per minute? Well, here it's important to remember that speed is given by the formula speed equals distance over time. Well, here's the deal. The distance, if we were to cover the entire circumference, it would be 16 pi centimeters over the 60 minutes. So we can do that, and we can write 16 pi centimeters was the distance divided by the 60 minutes. Now, simplifying by dividing both numerator and denominator by 2, initially you can get 8 pi over 30. Okay, now the units for this ones are centimeters, the units for this ones are minutes. Okay, don't forget the minutes here. And we can divide by 2 one more time. So we get that this now becomes 4 pi centimeters for every 15 minutes. So in reality, we can simplify this and say, well, we have a speed of 4 pi over 15 centimeters per minute. So it's the actual speed that the minute hand is moving. Now lastly, part C, what is the angular speed of the tip in radians per minute? Okay. Well, angular speed is given with a very interesting formula. Angular speed is simply omega, this is the Greek letter omega, equals theta over time. So we're going to take the angle. We can take the whole angle around the circle of the watch, so that would be the 2 pi over the time, which is 60 minutes. So omega, or the angular speed, is just 2 pi radians divided by 60 minutes. Now by dividing by 2, both numerator and denominator, we can get that this is simply pi over 30 radians per minute. And that's our angular speed here. Okay? So that takes care of the 3 things that we were interested in, which was how do we find the actual distance around, okay, for a specific amount of minutes, what is the speed the tip was moving, and how do we find the angular speed. I hope you have enjoyed, and thank you for watching.